found this JavaScript library and I thought, well, how hard could it be to port just the necessary bits to Elm? You have to become an interpreter of the code base yourself.
Hey folks, welcome back to Elm Town. I'm your host, Jared M. Smith. We'll be visiting with Andrey Kuzmin today. But first, let's talk about our sponsor, Logistically. At Logistically, we make intuitive software to help logistics teams make better decisions and improve efficiency. We build the front end for all new features in Elm. If you're interested in our mission and enjoy writing Elm, please drop us a line, elmtown@logisticallyinc.com. I'll put a link in the show notes. Now, let me introduce Andrey Kuzmin. Andrey is a software engineer who loves concerts, yoga, and functional programming. He currently works at Framer. He is a longtime Elm aficionado and game maker. Some of his Elm contributions include organized the Elm Berlin meetup and Elm Bridge from 2017 to 2020. He created several games in Elm and led several game jams, notably Moji, a WebGL platformer that fits into a 64 by 64 pixel screen, which he presented at ElmConf 2017, and the collaboration with me on Elm Pool. He maintains the Elm Explorations WebGL project. He's published Elm Physics, Elm OBJ file, contributed to the Elm language server, including recently adding Elm language server support to Zed, a high-performance multiplayer code editor from the creators of Atom and Tree Sitter. Andrey, welcome to Elm Town.
Hi, Jared. How's it going?
Good. I'm glad to have you on. So one of the things I wanted to do to get started here, I usually start with asking about how you got it started in computing and programming, and we're going to get to that. But first, because you have this on your GitHub that you love concerts, I wanted to ask you, do you have a favorite concert or band that you like to see in concert?
I can talk about the concerts I went to recently. So one of them is a band called Deerhoof. They play like very, very interesting and peculiar music, like using guitars. And I really liked their last album because they started to sing in Japanese. Their singer, she is Japanese, and before they never sang in Japanese, but then all of a sudden they started singing Japanese, and I learned Japanese. So it was like it's really fun, a really fun concert to go to.
So you've learned some Japanese, and so you had this connection with that for sure, and you like this interesting guitar stuff that they do, right? Then, actually, I did have a question to ask you about natural languages. So how many natural languages do you know?
Like in my home language, Russian and English, I can speak fluently. And I've been learning German because I live in Germany. I've been living in Berlin for about 9 years. I've been learning Japanese on and off, like maybe 15 years ago. I learned it for a couple of years. And then most recently, because I got to travel there a few times, I picked it back up. And now I'm still actively learning Japanese. Twice a week, I'm attending an online classes.
Japanese is the one that you're focused most heavily on, but of course, you have the English and Russian or fluency, and then German as well. So do you think that English being a second language has affected how you program in general, or because you're fluent, has it not been a big deal? Do you have any insight into that?
I'm not sure exactly about this. I cannot connect my language to the code that I write. I think English has a lot of flexibility in it. So I think it's more interesting to talk about German or Japanese, where the grammatical sentence kind of makes sense in the programming way. I think that probably makes you be a bit better at like logic and writing code, because you write code. You write down logic.
I guess to help me understand that, you are saying that because German is more logical in the syntax and more strict, and Japanese, then those languages are better suited for training your brain to program. Is that kind of what you're saying?
I think so. I think so. Yeah.
Yeah.
Both languages have this kind of frame-based structure where you have like a grammatical structure with placeholders where you can put words, but only in the places where they can be put. And it kind of trains you to program in a way.
Yeah. Okay. That's pretty cool. Yeah, that's really interesting to think about. Okay. Well, let's get into this standard starter question then about how you got started in computing and program, kind of how you began and what motivated you to get into it.
Oh, I started programming a very long time ago. I think I was still in the secondary school, and I think the first thing that I was programming was using either Quick Basic or Pascal or both. I was actually trying to make some games, and I was writing a game in the shoot 'em up kind of style where you have a spaceship and you shoot up, and then there are enemy ships coming at you. And I only managed to have like one enemy ship there moving on the screen. And then I thought about like, what should I do to add the second one? And you know what I did? I just copied the whole code for the first one, and I changed the variable names to have like two. Damn it now. And I got two enemy ships on the screen. That was amazing.
Nice.
And later on, I learned about arrays and how you can have main things on the screen.
Cool. Well, you were able to take the knowledge that you already had and extend it, right? So, yeah, that probably also reinforced the power of arrays in that respect. So you're like, oh, wow, this is much easier.
Yeah, and after that, I continued using Basic. I think I used Visual Basic. I had a friend who implemented like a small kind of 2D library using Visual Basic, using Direct Draw, and I used that, and I made like more complex games. So there was a platformer game I made together with the map editor. There was also like a kind of a shooting game, like looked from the top, and there was like a person in the center of the screen, and you could like move the mouse, and the person would rotate and shoot in different directions.
Okay. And you said this was in Basic?
Yes, this was using Visual Basic. After that, I studied at the uni. I studied computer science, and then I started working as a kind of a full stack engineer. So I was doing a bit of backend. Some of that was in PHP and like early days of Ruby on Rails. Then I learned Python. Then I dove deeper into front end. Like Node.js was starting, and then I learned front end frameworks. My first one was Backbone.js. Then was React. Yeah, this is how it all started.
Sure. So you went to the university and studied computer science, and then you were becoming a full stack engineer, learning all these different languages, moving from languages that, were full stack to front end specific things like React, Backbone. And then I'm guessing this is leading us to Elm. Do you want to tell us a little bit about how that came about?
Yeah, actually, I got into Elm through React. I went to one of the React Europe conferences in Paris, and at that one, Dan Abramov presented his time traveling debugger and Redux, and yeah, he mentioned Elm, and it got me curious, and I wanted to try it. So and I wanted to try it for something fun because I mean, free time is for doing something fun. So I implemented a game. It was like a copy of the Tetris game. like it was a clone of the existing game. It was fun to think out in the functional way. It was quite difficult for me to get started, even though I studied some Lisp at the uni. It was still, I think I forgot all this knowledge and I had to break something in my head in order to start thinking in terms of immutable functions.
Right. Okay. So I like that phrase, break something in your head to start thinking in that way. But yeah,
Well,
okay. So
there were some established connections, like in order to program in object-oriented style or in procedural style. And like in order to start thinking differently, you have to forget about the other ways of like how you used to do things.
I think about it as I can put that stuff into one box, and then over here in this other box is all the functional concepts. But then sometimes I will think about certain concepts that pull over. I'm like, okay, these things, I guess it then kind of becomes more of a Venn diagram where these parts overlap, but there are these two sections on each side which are independent. So yeah, that's really interesting. Okay. And this time traveling debugger was something that motivated you to start this initially, right? Building this, I believe it's called Flatris, the Tetris clone.
Yeah.
Okay.
So the original flight race was implemented in React, so it was already sort of functional, but not exactly.
So you were making this Flatris game, and how did it go? What did you think of Elm after you sort of broke your brain to learn functional programming?
This was my very first approach to making a game. I first started with very big lead blocks, and I have like this equal this, and then that equal that. So it still looked a bit procedural because one thing's like I thought about them as one thing happening after another thing. Then another thing I saw is that some logic that would be very easy to do in imperative programming in Elm, for me, it costed me a lot of lines of code. And then seeing this in Elm, I started thinking like, does it have to be this way? And as I learned more, I was able to change the data structures in order for the operations on them to become shorter, like more concise. So for example, like when modeling Tetris pieces, you would think of, I probably need like a two-dimensional array to represent them. But then, like, how do you implement like other, like iterating on all the pieces? So you would have to iterate on over the blank spaces too, and the logic gets like pretty complicated. So what I did instead, I represented all the pieces as a list of coordinates for each of the squares that it occupies, and that like really helped me to shorten down the code and the operations on that, because I could easily map over like all the occupied blocks, all the occupied squares for each piece.
Right. Yeah. So you changed the data structure and it made the code much nicer for this FP style, functional programming style. I think there's a lot of power in how you model the data. And I've noticed that I can sometimes tell when I don't have it right for that reason, because the code's a little clunky or I have to write a lot of extra stuff, some helper functions. And then I notice when I've made an improvement because all this stuff goes away, right? Like I'm like, oh yeah, all right, this makes sense now. I've kind of remembered or learned some way to model the data, or just tried changing it. And because Elm is so good at telling you what you need to change, of course you can make that change fearlessly, right? And then and then go fix all of the compiler errors, and then it works again. So that's pretty beautiful. So you have at this point broken your brain. You've learned Elm. What comes next?
I really liked it, and I liked using it in my free time, or like after work, on the weekends. And I think that the reason why I kept coming back to it for like trying it for other games too, is because I didn't have to think about, setting up Webpack, like configuring all the front end packages, because Elm gave me everything out of box. Like I could create something just using Elm, and that kind of brought me back the joy of programming for fun.
I feel like for me, because I had a similar transition from trying to do functional style JavaScript to then learning Elm, and I was using JavaScript on the front end, back end. I had some Node.js experience, and one of the things that I found was I hadn't had to deal with Webpack. I think this was Grunt and Gulp JS days, so that ages me. But yeah, but the point there being that there were these other tools that were churning over that I had to keep relearning. And then even the libraries, even if I was going to use the same library, if it stuck around that long, then I had to figure out, oh, do I need to upgrade? There might be some changes. How does this work if it works differently? What's the documentation like? How do I use it? I can't rely on consistent documentation and a nice compiler error message if I don't understand something. So yeah, that's certainly something that I think for me, I thought about it as like this just overwhelming kind of overload of all the things that I had to pack in. But with Elm, it's more freeing, and I can kind of focus on the thing I'm trying to build. So yeah, that makes sense.
And then the second thing that I noticed was that me like toying with Elm and making some things for fun actually made me a better programmer in JavaScript or TypeScript. And as you said, like you were using this functional libraries. I don't think that I saw like any big value in them. I was just a front-end engineer before trying Elm. But then I saw like then things clicked in my head. So I could write React that looked really nice, and I took a lot of things from Elm. Like for example, like if you have a function like why, like you should only pass the arguments that are actually used in that function. And sometimes folks in the React ecosystem, they don't pay too much attention to this. So you have components that get a lot of properties and use only a few of them. That was one of the things that I learned. Another thing was actually using Redux, probably the way it was meant to be used. When I worked at SoundCloud, we worked on an Xbox app, and we had one big store that represented the whole UI state, plus the state of the things that it fetched from the backend. And then all the things were passed down to React components. And a lot of that was like really influenced by the way I would write Elm code, and was really like nicely structured. Like sometimes I don't feel very proud about my front-end code and JavaScript code, but the application was structured very well. And some of the pieces of this application were then later on taken into some other code bases. Like I think the mobile website have some pieces of the audio integration.
Oh, cool. Nice. And where were you working when you built this?
It was at SoundCloud for Xbox and Windows, like a kind of Electron-like, but using Microsoft alternative.
So you were at SoundCloud using Elm in your free time, but then using the knowledge that you gained from that experience and then applying it to your work code in React. Okay, cool. Excellent.
So heavy reliance on union types. They're called tagged unions, what we call custom types in Elm.
Right.
Because TypeScript lets you do this. And when I learned about it, I just started using this extensively to represent different states. There was one really complex landing page that I worked on, and it had so much logic and so many different possibilities, depending on if you are already a subscriber or not, or there is a promotion, or you are in the process of applying for a student discount, and like all the different prices. So you have another type of subscription, and you're getting discount because of that. So it was an explosion of different possible states. And yeah, the approach was to start with a spreadsheet and have all the inputs, and then fill in the spreadsheet and figure out what states could be unified, and then distill them into different constructors, different cases, and I combined all these cases into one big union type.
Very cool.
That logic could be really tested without requiring testing any browser DOM. Could be just like one function that took all the inputs and produced this result. So you could be pretty sure about what you're going to show to the user, depending on all the different all the values of the different arguments.
That sounds pretty nice. So, yeah, you've been able to extend this knowledge, this experience with Elm into other places. I know at some point you worked at Arrival and you got to use Elm. Is that what comes next in this journey, or where are we at now?
Yes, so I worked at Arrival last 3 years, and I was specifically hired for my Elm skills, especially doing 3D in Elm. Ian McKinsey was my colleague at Arrival. So we used our libraries there, like we used Elm 3D Scene, well, of course, WebGL, because it uses WebGL under the hood. And it was a lot of fun. I didn't spend all my time programming in Elm at Arrival. I also picked up some Python. Well, I used to do Python in the past, but not Python 3. And I also programmed in Rust there. But as for Elm, I think one of the cool things I've implemented some camera controls, where you could you see there was an app with the 3D view of a part, and you could zoom in, zoom out, pan, and rotate that, and it was really intuitive. And I contributed translucent colors to 3D Scene, so you can have see-through polygons in there.
Wow. So your work at Arrival also contributed back to the libraries that you had made, and so they were improving through that process. And so let me ask you this, if you wouldn't mind to describe a little bit about how this product worked in relation to what Arrival does. Maybe explain to folks a little bit about that.
I worked on a team that was building tools for design engineers. And I use the term design engineer. I know it has a different meaning now in front end, but these were actual design engineers, so people who for design parts for product, who are industrial designers, and they use CAD software to design parts for the vehicle. The idea was to do some assessment on the parts, so they could upload their design and get some feedback about how it could be improved. And of course, there was a very big bulky pipeline in the backend that was doing all the heavy machinery for this, and the Elm app was used just to present the results.
Right.
And in the results, you could see the part and some information about it and some suggestions about the design.
Very cool. And so these parts would be going onto vehicles, correct?
Yeah.
Okay. Nice. So you got to, after being in the Elm community for a few years, just on your own free time, right? You got to apply this to your day job. Do you want to talk a little bit about what you're up to these days?
I've just joined Framer, and I've been with Framer for about 3 weeks now, I think, or this is my 4th week there. And I joined Framer as a product engineer. So even like before arrival in SoundCloud, I was not only doing front end, but I was also doing back end. And I'm kind of working in both at Framer too. What I think I like is like I enjoy in general delivering some things that the users are using. So the things that the users can interact with. I think I was missing some of that when working at Arrival because the user base was only internal customers, not the whole world. But Framer has like such a big exposure. And then another thing that is cool about Framer is like unlike other similar products, Framer like really fosters creativity. Like all the Framer websites, they have like lots of heavy animations and effects and scroll and all of that. And the general like mission to make the internet more creative. I'm like really down for that.
Yeah, that's really cool. And so this time you're not using Elm, but certainly I think as you mentioned before, the experience of having used these concepts, you can take those into the work that you do today. And who knows, maybe you'll find a place where Elm makes sense there as well. But certainly you have the opportunity to have a large impact because of the user base there. So yeah, that's exciting. Cool.
Yeah. So I think that my work at Arrival made me open for trying out other languages in general, because I worked with folks who programmed in Python, but without a lot of experience in software engineering and not even knowing about the type system. So trying to figure out how that code works and add types to it, like getting back to the comfortable state of things, trying to make them like it's not like the things are not like super strict on types like Elm, but to have like certain structure in the code and certain guarantees is good enough for me. I used to be like a purist. I used to like be really strict on things. I think you have to draw the line somewhere and like being productive or like spending a lot of time tinkering and polishing your code base. And I think it like I think Elm is still stays with me. Elm is still in my heart, and I'm still using it in my free time. But I think other languages are also fine, and I like when there are many different programming languages in general. I like, trying trying out one language and trying out another language, then thinking about, oh, there are some similarities, but then they're also different in some way, and you could borrow lots of ideas from them. Like I find Rust very interesting because it has a lot of it has the very strict type system that is very similar to Elm, but then it adds the concept of the borrow checker and it makes you think about the memory. And for example, you don't have a problem in JavaScript to choose what to use to store a number because you only have a number. Like even if it's a float or an integer, you get a number. well, Elm adds types on top of it and can make it like a float or an integer. But in Rust, you have to think about integers, unsigned integers, like floats, and then uh, they can have different sizes too. And that's kind of fun. Like you feel like you're closer to the machine when you have to make these decisions.
Right.
And actually, like when we just started, we were talking about integrating that with Elm, and one of the bugs there was because Elm's language server is written in TypeScript, and it uses the package from Microsoft that helps you implement a language server. And in that package, I think there was like one part of the API was reporting a progress of an ongoing operation, like indexing your files. And in the specification, it is declared as being an integer, and as like an integer percentage, like going from 0 to 100. And in JavaScript, they forgot to round it, and it was sending floats. But Rust was very strict about it. Rust was like, let me try and parse this as an integer because the specification says so, and it cannot parse it. So that bit was broken. I had to contribute to the Microsoft library in order to get this bug fixed.
Yeah, that's really interesting. I like this idea of, again, you've sort of broken your brain. You went from being really, you started out, you were this object-oriented programmer, then you broke your brain to learn functional programming. You were a purist, though, in that you wanted things to be exactly as they should be. And then you kind of went back and had to get into a Python code base where things weren't as strict, and this sort of broke your brain again. And then you're learning Rust, and so now you've migrated into thinking more about how the machine operates at a closer to the machine level, anyway. Okay, very cool.
I've been trying out some embedded Rust. So trying to program on a Raspberry Pi Pico and then trying to display pixels on a tiny screen.
Yeah, you migrated the emoji font to that, right?
Yeah, that's a pixel font that Nadia, my wife, has designed for the game, and I thought it would be cool to see it on the actual pixel display. That was quite a fun project. I also I also played with Tree-Sitter so I wanted to use the Elm package as the source, as the configuration for the Rust crate. So I added it as a GitHub module, and I used all the images for all the glyphs. But then I also parsed the Elm source code, and I got like some playlists from there, and I brought them into the code gen that I wrote in Rust.
Whoa, that's really cool. You parse the Elm to pull it into Rust using Rust?
Yeah.
Okay.
Like the kerning tables, the distances between the glyphs. So that was the first crate that I published in Rust. That was my first Rust crate.
Okay, cool. We'll add links to your social media. I know you post that stuff on there sometimes. So yeah, sounds good. I want to switch it up here a little bit. I got a question here from Urkel Selman. He says, quote, about Andrey, what captivates me is his remarkable knack for code comprehension. There was a time when I questioned how he managed to translate a physics engine from an imperative language to Elm. His answer was quite extraordinary. He claimed to be able to run code in his brain without fully comprehending it. I'm inclined to believe in this rare capability of his. During the interview, it could be insightful to delve into what the experience is like for him. Does it resemble some form of synesthesia or a different cognitive phenomenon? So synesthesia here being, is it something where you go from a how you think about it to a different sense, like a sense of smell or a sense of taste or color? Or is it something like that, or is it? Do you have any idea of how this works in your brain, or maybe you could just kind of describe what it's like, and then we can go from there and see how it goes.
Yeah, that's a that's a very interesting question. And it was indeed like that. So I ported CanonJS into Elm Physics. So now Elm Physics has diverged as I learned more about the actual things in the code, what they meant. So how I got to do it in the first place, I made some games in Elm and I got into WebGL, and then I thought maybe it would be cool to do some 3D things in WebGL, and then I made a Rubik's Cube game, and then I thought, okay, maybe I can make something else, and there was a game jam where the topic was randomness, and I thought that can I make like a physically simulated dice? And in order to make dice, I had to do some physics. And then I found this JavaScript library, and I thought, well, how hard could it be to port just the necessary bits to Elm, just to make it possible to like drop drop the dice and then see bouncing and landing on one side. And I can read JavaScript. This is one thing that I'm really, really good at. I can read like the worst ever possible JavaScript. I can figure out where the data is coming from, what kind of transitions, what kind of where it is mutated. And then another thing is like kind of in order to do this, in order to port like a highly imperative code base to like a purely functional code into a purely functional style, you have to see what are the dependencies, where the things are mutated, where they are not mutated, and establish some sort of boundaries. Like if you see that from this part of the code, like only this is mutated, then you can have you can implement a pure function for that. For some like highly imperative algorithms, what you do is you implement a recursion and you take all the local variables that are changing and you make them into an arguments of your function, and then every time they change, you call your function with the new values, and this is how it can update them. But yes, like I think this has like I think in order to be able to do this, you need to have like years of experience of writing code and seeing any possible code, and you have to become an interpreter of the code base yourself in order to see what like how it works. So you have to be evaluating things in your brain, and you have to have like a Rust borrow checker in your brain. Maybe that's why Rust. I found Rust very interesting because like a part of my brain has been doing this already. Yeah.
Nice. Very cool. Okay, so you have a capability of understanding code when you're reading it and being a sort of interpreter, like you said. Do you have a visual way that you think about this in your head? Do you kind of see this, or is this just kind of standard thought? Or
I don't think that I see it. I think what I see is the code in the editor and the variable names. It's not that I have like a visualization of a graph of some dependencies in my head. Like, I mean, it probably exists, but I don't see it as a visual thing.
Well, this kind of relates, I think, to another question that I had. So what have you learned while designing the API and writing docs for your Elm packages? One example I want to reference is your API design sessions with Evan on WebGL. Are there any specific things that you've learned from that? It sounds like maybe this one where you talk about finding all the mutations and establishing boundaries, that seems like that could be something related there, but is there anything else, or maybe dive a little deeper into that?
How I got into WebGL in the first place. I made a game, and then the new version of Elm came to be, and Elm WebGL stopped working. And I realized that there was no one behind the package anymore. And it happened to be at the Elm meetup in Berlin, where I met Noah, who was also highly active in the Elm community back in the days. And he helped me to migrate the WebGL library to the newer version of Elm. I think it was this version where Elm stopped being functional reactive programming, where when Elm dropped signals, so it was like a fairly big change in how the underlying JavaScript code worked. So with the help of Noah, I managed to migrate it, and then wanted to release a newer version of this. And in order to do that, I had to go through the review process with Evan. And this is how our sessions came to be. And I think they are recorded and it's still available. I do not remember what we discussed there. Most of the things, as far as I remember, most of the things were about making certain states irrepresentable. It was about seeing what is possible to do in WebGL, what are the possible combinations of values, and coming up with the best Elm types to represent these. So it wasn't about mutability per se. I think it was already like the main API didn't change too much the way you input data, the way you tell WebGL what to render on the screen. That was mostly the same, but with the newer version, there were less possibilities for you to run into the white screen, like when something is broken and is not working. Mm-hmm. Because like the impossible combinations were made impossible with types.
Well, I think that's certainly a core concept there that is good to understand. There were some, I noticed at the end, I just watched part 1 yesterday, so I have a little bit of that in my brain, but toward the end of it, and I'll add a link to these videos, but toward the end of it, there were some general tips on how to document things that I thought were pretty valuable too. So I'll add a link to that specific part of the video. But yeah, okay, so you learned some tips, or maybe we're kind of guided into using some. Maybe you already had this knowledge, but at least worked with Evan on making these impossible states impossible, sort of changing the API to work a little bit nicer and cleaner. I think there were some cases where, there were some places where you could pattern match on cases on custom types, so it was exporting all of the values instead of making it opaque, and so I think that was changed as well. So yeah, that's a good one.
And I think like after that, I took some of that knowledge and I worked on another package of mine that like came to be later, Elm OBG file, and I think I'm really proud of that one, how the API turned out to be, because so the Elm OBG file, it lets you load a 3D geometry from an OBG file, a wavefront OBG format that you can export from Blender, 3D software. But what's interesting about this OBG format is that it can contain sections. It can contain multiple objects defined in the same file. It can contain multiple groups, and they may have different geometry in them, or the same geometry but with different parameters. The parameters may be a position and normal to the surface, or a texture coordinate, like it tells where this vertex is on the texture. You can find it. And what I wanted to have is a package that lets you get all that information from the file and then easily use Elm 3D Scene. And Elm 3D Scene, it defines its own representations for materials, for different materials. Like for some of them, you need texture coordinates. For some of them, you need normals, and so on. And the way this was implemented, that was, by the way, highly influenced by my collaboration with Ian McKinsey, and I got lots of tips from him too on working on this project. How it came to be is, what if this loader was a decoder, like a JSON decoder? So you could kind of parse this representation, but then you could decode things that you need from it. And it worked really well. And it allowed, for example, to store multiple parts of the same thing in the same file. So, for example, if you have a car, you could store like the car, the wheel for the car, and maybe a convex shape for the physics to represent the collider. So you have the collider shape that usually has to be coarser than the visual representation, because for a collision, it's nicer to work with simpler geometry, so that it will be performant. And you could store this whole, like everything in the same file, and then you could drive the loader by combining the decoding primitives, and you could decode the model of the wheel, the model of the car, the collider, and then put them in your own representation for the car, like Elm 3D Scene mesh and Elm physics body. And then you could like both render and simulate that. And I think this is a very powerful concept, and it made like a really dumb OBJ format into something that can maybe even compete with like more complex formats that other people use. You could think of different hacks. Like, for example, you cannot represent local access. Like you cannot have a scene graph in the OBJ file. Everything is in the same coordinate system. But what you can do, if you can place line segments to represent the coordinates, the coordinates basis X, Y, and Z, as like three line segments that represent vectors like this. And then you decode it into Elm 3D Scene's frame 3D. And then you can use it to represent like where you want to place a part of the geometry.
Wow, cool. So you worked with Ian McKinsey and with that, and it seems to me like you probably were able to gather a lot of the knowledge from building other packages and in the past and use those as well, and experience with, I think you mentioned JSON and decoders, and so using those concepts and then applying them to this. So you have done a lot of work with 3D, you've done a lot of work with games. We're about to get close to the end here, but one question or one thing I wanted to mention was you presented at Elm Japan meetup earlier this year, and kind of going back to what we were talking about at the beginning, you're interested in and learning Japanese. Do you want to talk a little bit about that presentation?
This was actually my third or the fourth presentation. One of them was remotely, but the three of them were actually in Tokyo. And because I was learning Japanese, I was thinking like how hard would it be to actually do that presentation in Japanese? So in the first three presentations I made, I wrote down things I had to say. And then I asked my Japanese friends to fix all the mistakes. Then I read this over maybe 3 times. And then the last one was I started preparing for the talk very late. So I was working on the slides whilst already traveling, and I didn't have much time to go through the same process. As I was working on the slides, I met with my friend Yoshi, who was organizing the meetup. And I just tried to present this in Japanese to him, and he said, if you do it this way, then it's going to be fine. So I thought, okay, maybe I'll just YOLO at this time. And I did, and I think it was good. I didn't use a lot of difficult words this time because I just forgot all of them instantly when I started talking. So I used very, very simple words. Like mostly, it's, to use and to make are the two verbs that you really need to know if you want to show something, because you can say like, in order to make this, you gotta use this, or like using this, you can make this, and you can point at things, and that will work fine. But I think it also turned out like really fun, and it seemed that the folks enjoyed my presentation. I was actually presenting our Elm Pool, the pool game that we worked on together with you, Jared.
Right. Yeah, that's really cool. So I like this that you, I guess maybe accidentally, but you were forced to be a little more on the spot with how you spoke. And so this created a bit of a limitation in the words that you use. But I think that's good to set those limits and then make that possible. It seems like that's sort of breaking through another barrier in your brain to be able to be that conversational, if you will. I guess even though you were giving a presentation, but that's really neat. And so that you think went pretty well. You presented it in Japanese in Tokyo, and yeah, so that's a lot of fun. Before we get to picks, is there anything you're excited about now?
Yeah, I think that there was one really fun project that I worked on recently, was the animation that I made for this podcast. And with all the knowledge about 3D, when I saw the logo, I thought it would be really cool to animate it. And as we learned, the logo wasn't really designed in 3D. So the logo was designed in 2D. But because of some prior knowledge of Blender, I could trace it into 3D, save it in the OBJ format, and then load into Elm. As for animation, I'm usually using Matthew's package, Elm Animator, and that worked really well. Like, even without knowing all the 3D geometry stuff, when you read that code, you just have a custom type representing all the possible animation states, and changing from one state to another is just changing that one value, and then everything else just happens. And all you need to store in the model is that timeline of that state, and constantly have to be updating it with the request animation frame. I think I will try and write a little bit about it, because there were a few things that I learned myself actually about this when doing this. Yeah.
Yeah, that was so cool. So just to give a little bit more, I was working on this Elm Town website rewrite, and it was originally some template with the publishing provider that I use, Simplecast, but I wanted to write it in Elm, of course, and I was using Elm Pages, and I showed it to Andrey, and it was like he was inside my head, because I was thinking, I was like, I wonder what it would be like if we animated this. And before I even could suggest it to him, he already wrote back and like, this would be cool if we animated it. So I was so excited. And when I actually saw him make it in action, you make it in action, I was like, yeah, just blown away, especially the subscribe animation. I mean, the whole thing is incredible, but like, I don't know, it just, It's really cool. I recommend going to elm.town and checking it out. You can subscribe with an example email address. That's fine. You don't have to put it in if you don't want to, but if you do, that's great. But checking that out is really cool. And yeah, so shout out to Matthew Griffith for Elm, for the Elm Animator package. Yep. And I did use Elm UI as well by Matthew Griffith. Let's see, Dylan Kern's Elm Pages used. Oh, there's so much there. Of course, your used Elm OBJ file, right, on that? Yeah. Yeah.
And Ian's packages
Yes,
for
of
rendering.
course. Yeah, they're huge. They make the code just so nice and readable, even for someone like me who is very naive and understanding of 3D. So yeah, that's a lot of cool stuff in there. I need to get that code out there, linked up, and yeah, maybe if you talk about it before I get this published, I'll put a link to that. And otherwise, yeah, you ready to move on to picks? Do you have anything else?
Nothing that I can think of. Let's move to picks.
Okay. Actually, there is one thing I wanted to say. I just wanted to shout out to Maggie Appleton, who created the original logo. You mentioned it wasn't actually written in 3D, but yeah, that is a really cool Elm Town logo. If you know the Elm Town logo, you're familiar with what it looks like, but it's just a really cool way of taking the tangram and then kind of rotating things and making it sort of look three-dimensional there. So that was cool. She said it was fine for us to render that in 3D and show it. So yeah, shout out to her as well. All right, so what picks do you have for us today, Andrey?
One of the interesting things that I find about Elm is that through using Elm, you can learn about other things by modeling them, because Elm like really makes it nice to describe certain things and put them in types. So you end up thinking a bit more about the domain that you are working on, and it makes it in such a nice and playful way. So, for example, I once learned about how to render text with WebGL, and I did it in Elm. It was like a very, very fun and eye-opening experience for me. And the second thing that I want to say as a takeaway is try to make games with Elm and see where it goes. Try not to overcomplicate things and like work on your game engine. Just try to make a game, and you will have a very fun and rewarding experience.
Yeah, I think that's good advice. Certainly, I've only made one game in Elm, but working with you, collaborating on Elm Pool was a lot of fun. And I think that because we were able to structure the code in such a way that there was really no like confusion in which parts of the code that each of us had to do. And so that was just an awesome experience. And it, like, at least for my part, it didn't seem like it was a lot to do. Of course, I wasn't rendering 3D objects or anything, and doing physics, but it was a really cool experience. So yeah, I think that's good. And it was the only time that I've participated in a game jam, and so that was a lot of fun too, having a deadline that we had to get to. So yeah, those are good picks. I want to go back to the other one that you said, rendering text in Elm, because I think that sort of reminds me of what you're talking about, getting closer to the metal with Rust. That's kind of what you're doing here, where instead of just giving a string and having it render it in some predefined font, you're actually rendering that. So that is an interesting way to learn more about how that works as well. So you've maybe broken your brain in a in another way to understand that. So very cool. My picks, I have two of them. The first one is unrelated to programming at all. It is a band, Flaming Lips, And I mentioned that band particularly because you like concerts, and I've been to a lot of different concerts. I like a lot of jam bands particularly, but I saw the Flaming Lips live a couple of times, and under no influence of anything, it was a very trippy experience. And I think that it's a pretty cool show. I don't even know if they still tour or not, but maybe check it out on YouTube video. But it's a pretty cool thing to see. And then
I've seen them once,
yeah,
and it was really, really good. And also performance-wise, like when he gets into like a ball and then goes over the crowd, that it's like, wow.
yeah,
Or riding a unicorn through the crowd, that was quite fun.
yeah. He got into the ball when I saw them too, and that was pretty crazy. It was a pretty neat experience. I definitely recommend it. So yeah, it's fun. But yeah, so my second pick is the Z editor. We talked about it a little bit earlier. We've added mostly Andrey with me there as moral support. Added the Elm language server integration, or the Elm integration, including Elm language server. And I use it as my daily driver today. So I had mentioned when Mario Rojic had interviewed me on Elm Town 74 that it was not yet my daily driver. That was because the things that we'd worked on were not released yet. But since then they are, and I'm using it for Python and Elm every day. It's basically the only editor that I need. So yeah, check it out. And I guess that's it. Thanks to all the folks listening out there, and rate and share if you're enjoying the podcast. And I want to say a big thanks to Andrey for coming on this show. My projects are so much better for having you collaborate with me on them. So thank you for that, and thanks for coming to Elm Town.
Thank you too, Jared, for having me. Bye-bye.